Hello everybody to Sustainable River Basin Management Module 1, Part 4. We've been talking about economic growth models and alternatives to our current economic growth models in our last lecture, and we were touching upon the concept of green economies. Now, this was one of the concepts or one of the focus points to changing our current economic models. And the second component of it was ecosystem carrying capacity. And we will be specifically talking about ecosystem services and the planetary carrying capacity. Now, looking at ecosystem services, we essentially can differentiate four major services which we have to account for in whatever we approach in for resource consumption or resource recovery. And this was summarized in the first time, for the first time in this Millennium Ecosystem Assessment in 2005. The first of the ecosystem services recognized was the provisioning service. This means any products obtained from ecosystems. If we apply this to our rivers, then this would mean water, freshwater availability, water abstraction for irrigation or for drinking water supplies. The second important ecosystem service that we take from the environment are regulating services. And regulating services, we mean any benefits obtained from the regulation of natural processes. So this essentially means processes of climate variability, of rainfall, of water availability, of water cleaning processes, if we apply this to water alone now. The third important ecosystem service is our cultural services, and those are quite important, although not eatable or not something that we can sell or we can, from an economic point of view, account for. But those are benefits to people from a spiritual point of view or from a recreative point of view. They are very important. Anybody enjoys a waterfall or a lake or a riverside, and that is a cultural service. And then the fourth ecosystem service is our supporting services, and those are services that are necessary for the production of all other ecosystem services. And those are reproductive cycles, for instance. Those are also self-cleaning processes, buffering processes taking place in our environment. Now, notice that under ecosystem services, what we mean is what our environment, our ecosystems can do on their own. This does not mean any man-made intervention of, let's say, a flood control, building a dam, or by redirecting water or so. When we speak about ecosystem services, we mean the self-contained capacity of our environment to deliver those services. Now, an important additional component of evaluating environmental states is the so-called carrying capacity concept. And if we zoom to the largest level on our planet, then we have to look at the planet's carrying, or planet Earth's carrying capacity. And this essentially describes helps to understand and helps to monitor the Earth's systems dynamics needed to maintain our current climate state. This means to maintain our living conditions, which have been favorable throughout the geological time called Holocene till today, and has enabled us to develop as humans into civilizations. This also means, looking at planet Earth's carrying capacity, that we as humans have realized that we have influenced parameters. We have created an influence that shows as an impact, a negative impact on the carrying capacity of our planet, and that we also believe that we have, as humans, the capability to reverse unwanted conditions. So this is why this concept was developed in the first place. Now, an entire framework of systems boundaries applicable to the largest stage of our Earth, planet Earth, was developed and introduced in 2009 and very recently updated. Essentially, that framework contains two components: the science of planetary boundaries, which means to scientifically understand feedbacks and thresholds of our planetary system, to collect evidences and facts, to document or understand shifts and tipping points in the system. And it has as a second component the living within the safe operating space for humanity. Means that to take the information collected from here, the understanding that we gain from monitoring our planetary systems boundaries, and define a safe operating space. So this means there will be to find a range of acceptable conditions where humanity can live under good living conditions. So this means that knowledge has to be generated, it has to be managed, networks are required, and that at large social changes have to take place, incorporating sustainability concepts into the society, but also into governance structures in countries or for regions or for the entire globe. And this has to take place by engaging people, by visualizing, outreaching, and through public awareness and media. Now let's look at planetary system boundaries. What are those? And there are two essential publications which you should read seriously, very comprehensive, and also updates are coming up regularly on this, because that's a science ongoing fact-finding, ongoing research, and ongoing expansion of monitoring networks across the globe. There are nine so-called planetary system boundaries. There's what we call biosphere integrity. There's climate change as a system boundary, novel entities as a system boundary, stratospheric ozone depletion, atmospheric aerosol loading, ocean acidification, biochemical flows, freshwater use, and land system changes. You see a circle shaded with different colors, and the green color here indicates that the monitoring or indicator is within safe boundaries. The yellow here shows that there's an increasing risk that, or a very large uncertainty about the indicator, the range, the dipping point of the indicator, and the red indicates that we already in a high risk or beyond the zone of uncertainty. So what we can see here is that there are also, first of all, there are two of the planetary system boundaries by far crossed already, which is the case of the biosphere integrity, which includes biological diversity, species numbers, the extinction of biological species. This boundary has been crossed by far already, and another very serious or cross boundary we can observe for nutrients. Very important, phosphorus, we touched upon this already, and nitrogen being crossed. And whereas for the case of freshwater use and atmospheric aerosol loading, we believe that with at least the indicator that's been used right now, we are still within safe boundary conditions. Now, there are terms and also boundaries which were not defined yet, and let's try to look at those. The novel entities is a in a way not very distinguished term. What is behind that? Behind this is our organic pollutants, radioactive materials, nanoparticles, and for instance microplastics. This means those are all components which are created by human activity. Those are artificial components which would otherwise not occur in the environment, or would otherwise not occur in the environment at such a level of concentration. So for now, those have become such a high level of concern right now, as they have moved from being micropollutants to actually becoming very abundant in our systems, especially in water. And we don't have policies in place yet, and or laboratories or indicators that would give us any mean of measuring our situation and setting us limits and boundaries to that. So this is a research factor, which is, and a lot of activities and research are going into this right now. And the same applies to atmospheric aerosol, where we are referring to microscopic particles in the atmosphere which affect climate and living organisms. That is similar to the compounds produced actually from human intervention, which would otherwise not occur in the environment. Land use and land system changes are taking place, and one of the examples is deforestation, but in many other parts of the world we also see forest encroachment taking place. So this is a factor that is not very, an indicator which may not be very suitable, but what certainly takes place is a large wave of urbanization which affects land use in a almost irreversible way. Biodiversity, we have mentioned already, the loss of species and the extinction of species. Now, when we speak about planet Earth as a system, then what matters is how can we influence those parameters? How can we change those boundaries? And for that purpose, we have to understand feedback loops. And moving our biosphere integrity to the center of interest, we can group all the other monitoring components to the and connect them to our biosphere through feedback loops and highlight them in different ways. And what we can see is that climate change is one of the major impacting factors on biosphere integrity, and again also looping back, there's a feedback loop directly feeding back to climate change as well. So that is a very crucial relationship, which is sort of self-sustaining, a self-sustaining loop, which is very difficult in that stage also to change. If you look at freshwater use, for instance, the lack of fresh water or the lack of or the pollution of fresh water is a very influential feedback loop on to biosphere integrity, which again also feeds back to freshwater use in itself. So by understanding those relationships, we can create mechanisms to interrupt or influence these feedback loops, and we will be talking about this at a later stage. What can we do? How can we influence and change a self-reinforcing feedback loop in a wanted way? Now, having understood our boundary conditions, we also need to realize that we are in an interconnected world, and this was part of our sustainability definitions already. And looking at this figure here, we can see that we could list a number of global drivers, and this list may not be comprehensive. It ranges from chemical, from nutrient cycles which influence our greenhouse gas concentrations, to such social aspects like international terrorism. And those global drivers we may add to this list on our own, create unwanted outcomes. And those unwanted outcomes influence our climate, they influence our ecosystems, they influence our human health, and they influence economics or economic systems. So what we can see here is that most of these global drivers have a very direct influence on our ecosystems. And most of our global drivers also have a very direct impact on us, on our human health. Few of them have an impact on economics, economic growth, economic financial market shocks, and so on. And very few of those have an impact on climate change. Yet all of the ecosystems, the human health and economics are directly influenced by climate change in the way of floods or droughts, larger climatic events which interrupt economies, interrupt ecosystem services, or create diseases and kill people. So what we can see is that we can work on some of these drivers and try to influence some of these drivers, and still we may not be able to oversee what the unwanted outcomes will be versus the wanted outcomes. to the interconnected aspect, interconnection of sustainability, there's a multi-scale facet to it, and multi-scale from a geographical range as well as from temporal range. And I want to show you here an example of this multi-scale feedback loop. We have here an example of global climate change affecting the planet Earth at a global scale. Now, we can ignore this at one location and ignore it on one continent, yet it's a reality that is measurable. And this climate change can result in, for example, droughts on one continent, whereas there might be a flood on another continent. So it affects what happens at a regional scale. And this can trigger a number of actions and responses at the local scale. So, for instance, if we take this as an example that climate change increases the number of drought events, the duration of droughts, then this has a direct impact on agricultural production. So the entire agricultural production may decrease or decline, and people will be forced to look for alternatives. So they may move into fishing, for instance. And fishing is directly influenced by climate change again, where fish stocks have been decreasing or wiped out simply due to climate change, due to ocean warming, for instance. Yet an entire population here would be depending on this fishery industry. And alternatively, they may shift to subsistence production, subsistence livelihoods, and bushmeat hunting or wildlife-based livelihoods may increase, which again has an impact on biodiversity and deforestation. As a side result of droughts due to climate change, we may also have a higher number of diseases taking place, which may weaken the human population or may actually wipe out other species which are important to the survival of human populations. So this is to show that something that may be quite far away from one or ourselves has a very far-reaching impact on continents, on decision-taking and responses at local scales and for local societies and local economies. So this can, just like in this demonstrated case here, lead to a cascading crisis effect. And this is what we also are observing in many cases when we look across continents. Now, how can we describe our impacts, our environmental impacts? And for that, we use a term that is called footprints, and which essentially marks the relationship between global sources and global sinks in our current economic model. It essentially looks at the case of ecological footprint, which is the most wide or the widest expression of footprint is the area of productive land and water ecosystems required to produce a resource that is required for consumption, and the required land to assimilate the waste that is being produced from from the consumption, from the production of these producers. This can be anywhere. Those sources and things may not be connected. And this is what I want to show you here. If we take a look at the entire globe and the country division here, then we have here in our color code from the dark brown to the green, the footprint, which is 1.5 times larger than the biocapacity, and on the green, on the other side, the biocapacity that is larger than the 1.5 times larger than the footprint. Now, what we can see here are a number of countries where the biocapacity is fairly high, fairly large. And then we have a number of countries here where the footprint is extremely high, by far larger than the biocapacity. How can those countries function? So now this shows us that there's the source and sink relationship between countries. So there are countries which have a very high footprint, which essentially draw the resources from those countries which are sources, which are source countries. Those are sinks. And then we have countries which serve as an export for resources to deliver them to those which have a very high footprint. This interesting is that we have an extremely high ecological footprint in the Middle East countries. If you look at those countries, especially which I am pointing out here, those are extremely dry countries, arid countries. This is where the Sahara Desert is. It is quite surprising if you just look at a map how large the footprint is, and this is possible because the resources are imported. Water has been imported, water has been drawn from desalination. Those are economies which are served by other economies which are able to deliver sources to these countries. Now, we can take another example. Instead of looking at the ecological footprint and we can just look at the energy footprint. Here we have population in millions, and here we have the global hectares per person. So it's converted energy footprint converted into hectares to make it comparable. What we can see is that for North America, we have a very relatively small number of people forming or causing a fairly high energy footprint versus, for instance, Asia-Pacific region, where we have a very high population number forming exactly the same size of energy footprint per region. So we have on one side a low population and on the other side a large population, and by summing this up we end up having exactly the same energy footprint in those two regions. So whatever efforts are made to improve on footprints, may it be an energy footprint, a water footprint, or an ecological footprint, population numbers can actually set back all of these positive efforts made. So we stop here, and next time we will be speaking about the Holocene and the Industrial Revolution.